Okay, good morning class. Ito yung inyong midterm exam and we will discuss the solution and yung final answer sa midterm exam mo. Okay. So, kapag merong, for example, nagkamali yung check dun sa inyo, yung solution nyo, you can message me sa Black. Okay, sige, let's start. A square spread footing supports an interior 500 millimeter square column supporting a lead load of 1,800 kilonewton and a service live load of 1,250 kilonewton. The column is built with 24.1 megapascal concrete and it should be used 20 millimeter diameter longitudinal bars with Fy equals to 415. Okay. The depth of the foundation should not exceed 2 meters at the bottom and the preferred thickness of the foundation should be at least 450 millimeters. Okay. Then the top of the footing will be covered by soil. Okay, then yung unit weight ng soil is 18.8 kilonewton per cubic meter and meron siyang 150 mm thick basement floor. Okay, with unit weight of 544 kilonewton per cubic meter. Then yung basement floor has a surcharge load of 4.8 kPa. Okay, the observed value of the ultimate soil bearing capacity was 870 kPa. Use a factor of safety of 3.0 for the allowable soil bearing capacity and we will determine the following. First, determine the recommended size, recommended width of the square footing in meters. Okay, round up your answer to the nearest 25 millimeters. So our answer is 3,575 millimeters. Number 2, determine the recommended thickness of the square footing using a concrete cover of 75 mm and river diameter of 20 millimeters. So I already indicated the formula for the thickness, which is thickness is equals to the effective depth plus the concrete cover plus the rebar diameter. Okay, round up your answer to the nearest 25 millimeters. Okay. And lastly, based on the recommended thickness, solve in problem B, determine the spacing of the 20 millimeter rebar space to the nearest 25 millimeters. Okay, so ito yung inyong for letter B. So yun lang yung medyo mahirap ng pagde-design ng thickness. Okay, sige, let's start. Okay. So yung problem 1, ang sabi niya dito ay consolidate muna natin yung diagram of your footing. Okay, ang sabi dun sa footing, that is a square isolated footing with minimum depth of 2 meters below and a minimum thickness of 450 millimeters. Okay, so bakit meron siyang minimum thickness? Okay, for minimum thickness is yun yung preferred na size ng design. And para may ma-design tayo when we are solving for the width of the square footing. Then at the top, you have a slab of 150 millimeters and a surcharge load of 4.8 kPa. So before we start, kailangan nating alamin yung allowable soil bearing capacity. Okay. According to the problem, yung soil, factor of safety is 3. So therefore, your allowable soil bearing capacity is 870 by 3. Okay. So bakit magkakaroon ng factor of safety? Because yung given na problem is an ultimate soil bearing capacity. And as you all know, di ba, ang definition ng soil bearing capacity has a factor of safety. So therefore, this is your allowable soil bearing capacity. Then, solve for QE. Di ba yung QE natin is basically QA, yun yung net kung ano yung matitira dun sa soil bearing capacity. So, just subtract the surcharge load, this one, the weight of the slab in kPa. So, it should be 23.544 multiplied by 0.15 meters. Okay? The weight of the footing, which is 23.544 times 0.45 mm thick. So we will start using this thickness. Okay, minus the okay, should be times. Okay, minus the product of 18.8 minus 2 minus multiplied by 2 minus 0.45, which is the height of this one. Okay, kung ano yung height nito, di ba? That is 2 minus 0.45 meters. So therefore, you have your Q sub E, which is the effective soil pressure, okay, is 241 or 241.9336 kPa. Okay, and also to determine the area or the width. So gagawin lang natin Q sub E is equals to P over area, whereas your P is the load or the surface load that your footing will carry. So according to the problem, you have dead load and live load. So so basically the load combination is dead load plus live load, which is 18 plus 250 over the square area, which is B squared. So therefore, you have 3.5506 meters. To convert it to millimeters, you have 3,550 or 3,550.6 millimeters. So according to the problem, you will round up your answer to the nearest 25 millimeters or nearest 1 inch. Okay. So this is 3,550.6. So mas lampas na siya sa 3,550. Okay. So basically that is now 3,575 millimeters. So this will be your final answer. Okay. Next is number 2. Okay, yung number 2 medyo mahaba yung solution since pinapadesign kayo ng thickness, di ba? So we will use now the dimension 3,575 millimeters. Okay. So ang gagawin natin, ano ba yung problem natin? So according to the problem, okay. Yan. Yung hint natin is design based on one-way shear stress and two-way shear stress capacity. Okay, so basically katulad ng tunong ginagawa natin, you just need to equate the two yung demand and capacity, di ba? Yun naman yung basic principle of structural engineer yung pagde-design natin. Just compare the demand to the capacity. Okay, so ito. So yung naka-indicate na dito kung ano yung gagamitin yung shear stress capacity. For one way, that is phi 0.17 square root of F prime C. And for ultimate two-way shear stress, that is the least of this value. So kung i-compute nyo to, that is 0.33 lambda squared of prime C, 0.17, okay, this one and this one. Ang unknown lang dito, what is your alpha S? Okay, what is your beta? Okay, your alpha S is 40 since your column is interior. So nakalagay dito, the value of alpha S is 40 for interior columns. Okay, the problem is 40 kPa. So 40 yung ating value since yung square column natin is interior. Ayan, nakalagay interior. Okay. Then also, what is your value of the beta? Okay, according to the problem, your beta is the ratio of the long side. Okay, this is provision. Beta is the ratio of the long side to the short side of the column. Okay, so that is 500 by 500. So basically, that is 1. Okay. Sorry, bakit ganito? Okay. So if you solve for the shear capacity and compare for the two-way, ang mag-govern dito is yung letter A. So 0.33 lambda squared of F prime C. So basically, yung gagawin nyo lang dito, class, is just equate the capacity to the demand in terms of unknown variable D. So magso-solve kayo ng D. So quadratic equation, I think. So yan. So magso-solve kayo ng D. basically that is phi 0.17. Okay, then square root of f prime c. So you need to first solve for QU. Your QU is PU over area, and your PU is 1.2 dead load plus the 1.6 live load. Okay, 1.6 live load. Because ang tanging presence lang is that lang live load, and your area is B squared. Okay, so therefore you have your answer, which is your D is should be greater than or equal to 526. Okay, so this is for one way only. So 526 plus mo sa 75, yung concrete cover plus 20, you now have 621. And round up your answer to the nearest 25 millimeters. Therefore, your answer is 625 for one-way shear. Okay? And hindi pa yan yung final answer kasi kailangan mo rin siyang i-check sa two-way shear. Okay? Or sa punching. So for punching, ganun din in terms of D. So the governing capacity is yung value A, which is yung 0.33 lambda square root of f prime c. So that 0.33 lambda square root of f prime c is this one, yung 325.4927 kPa. And solve for D, I also get now 660.8344. Okay, then solve for T. So the total thickness, that is 655. Okay, so I think dapat hindi ito. Okay, so 655 should be 755.1185 for the thickness. Okay, so round up your answer to the nearest 25 millimeters, you get 775 millimeters. Okay, so comparing the two answers based on one-way and based on two-way shear. Okay, based on one-way shear, your required thickness is 625, and based on two-way shear, your required thickness is 775. So as a designer, you will choose the higher, okay, the higher value, because it will compensate the higher value will compensate the needed thickness for the other limb state. Okay, so ito yung thickness na to. So dito kasi your thickness should be greater than or equal to 625. This one naman should be greater than or equal to 775. So kapag pinili mo yung 775, pasok na agad siya sa one-way shear. Okay? So ganyan yung pag-solve for the design of the depth. Okay. And basically for number 3, okay, according to problem number 3, what is the recommended thickness solving problem? Based on the recommended thickness and solving problem 3, determine the spacing of 20 mm rebar. Okay, so basically, since meron ka ng BND, you can now solve for the required spacing. Okay, the formula for the spacing is, I think, bigay ko na sa inyo. So, ang nag-govern dito na raw, based on my calculation, is the raw mean 1. Okay, so ito yung required still ratio. And you can now solve for the spacing. Okay, so ganyan. I think the answer dito is 130. So convert nearest 25 millimeter spacing, that is 125. So round down po tayo pag sa spacing, ha. Okay, number 2, the wall footing is to be constructed on a clay with 0.7 meter below the ground surface. The footing is supported with a wall imposes a allowable load of 135 kilonewton per linear meter. And the unit weight of the soil is 17.3 and a cohesion of 15 kPa. So considering actus reagis general failure, NC and Q and gamma, determine the following. Okay, footing width should be provided to have factor safety of 3, ultimate bearing capacity in kPa if the width is 0.9. And what is the new factor safety? So this problem is already included dun sa binigay kong example problems in design of foundation. Yung link sa YouTube na binigay kong problem. So you can check the solution there. Okay, so ang ginawa lang naman dito is in terms of D lang. So nag-solve siya ng in terms of D and come up again to the quadratic equation and you can solve for D. Okay, so starting from A, then after that, change your D to 0.9 and solve for the new factor of safety. And I think lahat naman nakakuha ng problem na to. Okay. And number 3, so this one is the same dun sa, almost the same dun sa binigay kong example for, I think ano yun isolated footing with axial moment and subjected to axial and moment or axial and bending. Okay, so for this one, yung square footing supports 350 by 350 given yung axial load in dead load and live load and given yung earthquake moment. So tanging may moment lang is the earthquake. Okay, so using the load combinations, okay, so hindi ko nalagay dito yung envelope method So okay, hindi naman okay lang naman since yung given example problem ko is naka-envelope na. Okay, so anong ibig sabihin ng envelope? Ibig sabihin you will get the maximum ultimate loads based on the load combination. So it doesn't matter kung anong combination yung nag-govern. Okay. Solve for natin. So, insert tayo na. Okay. So, ang gagawin natin is ang problem. Okay. The problem is should be nominal beam shear stress. Okay. Dito pala dapat. Nominal beam shear stress, nominal punching shear stress, and the maximum design moment. Okay. So, ang una niyong gagawin class is solve niyo yung ultimate loads. Okay. So, set up niyo lang muna yung ultimate loads. Kasi ang hinahanap natin dito is yung actual. Okay, di ba yung actual? Okay, so therefore, solve for PU. Okay. Your P sub U comes from the two load combinations. So, straightforward, ang pinakasagot natin dyan is ang governing load combination dyan is 1.4 dead load plus 1.7 live load. So therefore, your PU is 1,400 kilonewton. And your MU, okay, so sino lang ba dito yung may earthquake loads? Okay, siya lang naman yung load combination na 1.3 dead load plus 1.1 live load plus 1.1 E. So 1.3 moment in dead load plus the 1.1 moment in live load plus the 1.1 moment in earthquake. Okay, so MU mo dito is 33 kilonewton meter. Okay, so ito na yung actual loads or actual ultimate loads ng ating footing. So based from that value, you can now solve for the following: yung nominal beam shear stress at ultimate loads, nominal punching shear stress, and the design moment. Okay, so ayan. Okay, so for the ano ba natin to? So ang pressure diagram natin doon, the pressure diagram is just like this one. So this value is 270.66 and this value is 307.85. So that is comes from the negative P over A plus and minus the 6M over BD squared, or yung since square to, so L times L squared, that is L cubed. Okay. So yan yung value. So for the one-way shear, ang value natin dito, okay, yung dito value natin is okay, I think 299 to. So value natin dyan for the one-way shear is 299.14 kPa. Okay? And ang value natin for the two-way shear, okay, for the two-way shear, so solve mo yung dalawang side, yung d over 2 distance. Okay, ang value natin doon is yan, ang value natin doon is 296.1 at the face d over 2 distance. And dito naman is 282.41. Okay. And after that, you can now solve for the VU sub P and the VU sub W. And you can now solve for the nominal punching and nominal punching and the nominal wide beam shear stress. Okay, for the design moment, okay, so ang gagawin nyo doon sa design moment, so solve mo again yung actual pressure. So for the design moment, okay, clear ko lang to. Okay, for the design moment, ang gagawin nyo class, so meron ka ng actual pressure which is ito, di ba? Ito na yung actual pressure mo. And ito yung inyong footing. And ito yung face of the column. Okay, so ang gagawin mo, di ba, ang critical section for the footing is at the face. So you need to find the pressure at this point. So considering this pressure diagram, ito, so ang gagawin nyo lang is sum up nyo lang yung moment at this point. So hahatiin mo to in two sides. So hahatiin nyo siya in ito. So basically kung ano yung makompute yung moment dito plus yung moment dito with moment arm this one and yung moment arm na ito. Okay? So that is how you solve for the square footing with actual moment and actual loads. Okay, so do you have any questions before we go to our first topic in finals? Hello? Okay. Sige. So I will check your solution, okay, within the week. So you will have your grades within the week. So open natin yung ating discussion for today. Yan. So mag-introduction na lang tayo. I think wala na tayong time. Okay. So today we will discuss the introduction to pile foundation. So right now we are now dealing with the deep foundation. So magso-solve na tayo ng mga deep foundations. Okay? So ano-ano ba yung mga deep foundations? Okay. So one example of a deep foundation is yung pile foundation. So ito yung mas pinaka mostly used na deep foundations. Okay. So I think na-discuss ko na sa inyo what are the difference between the deep and the shallow foundations. So since most of the design today is based on the pile foundation, so we will analyze and discuss only for the pile foundations. Okay, and also kapag dating naman ng board exam nyo, more on pile foundations yung mga binibigyan na problem for the deep foundations. Okay, so what are piles? Okay, so piles are example of the deep foundations. Okay, your piles are slender structural members made of steel, maybe made of concrete, or maybe made of timber. Your pile foundations are considered as a deep foundations, and your piles are used to transmit the load, okay, to the underlying bedrock or a stronger soil layer. Okay. So ginagamit kasi 'di ba yung deep foundation since yung topsoil mo hindi ganoon kayang i-carry yung actual load sa taas. So the solution is to provide a more deep foundations para matransfer yung loads dun sa mas malakas na soil layer or yung bedrock or yung stronger soil layer nyo. Okay, so that is the purpose of deep foundations. Okay. So kung hindi kayo nakakakita, kung hindi niyo na ano yung mga piles, kung ano yung ibig sabihin ng piles, is like this one. This is a foundation of a Burj Khalifa. Yung Burj Khalifa in Dubai. Okay. So ang foundation po nila doon is as a deep foundation, which is piles. Okay, so just like this one. Yan. Ito yung deep yung pile foundations. Okay. So for the need of pile foundation, so kailan ba ka ba pwedeng ano ba yung criteria or ano yung scenario para para masabi na need mo mag-pile foundations? Number one, okay, yung piles have been used for supporting the axial and lateral loads for structures that has like high-rise buildings, transmission lines, and highway structures. Okay. Okay, because itong mga itong mga structures na to is basically mataas yung actual loads o mataas yung load sa taas, and also mas susceptible sila sa mas malakas yung lateral loads. So 'di ba if you taken up yung earthquake engineering, 'di ba yung earthquake engineering, if you recall, the formula is seismic coefficient. Yung kung ano yung value of your seismic coefficient. So pwedeng 2.5 CAI RT times W. Okay, if you recall, yung isa pa, ito yung UBC 1997 okay, or the NCP 2015. Okay. So 2.5 CAI over RT times W. Then yung sa 0.11 CAI W, yung isa naman is I think 0.8 Z NV. NV I over RT. I don't recall yung V-min 1. And isa. Hindi ko naman recall yung dalawang meaning. Okay, so anyway, ibig sabihin lang nito is directly proportional yung lateral loads and yung total weight, okay, yung total axial loads, because if you can see, this is a constant value or coefficient. Okay, this one is also a coefficient. So basically, ilang percent ng total weight yung base shear, yung lateral loads. Okay? So, 'di ba, based on inertia, law of inertia, 'di ba? Kung ano yung total weight mo, doon lang din nakabase yung total na base shear na tatanggapin niyo. So, basically kapag mas mataas yung weight, mas malaki yung expected mo na base shear or yung lateral loads. Yan. So, ito yung mga example na yun. Yung mga matataas yung weight and expected to carry lateral loads. Mataas ang lateral loads. So, ito yung mga areas din na prone sa earthquakes. Yan, mga yan. Okay. Also, when the upper soil layers are weak to support the loads and support the load transmitted by the superstructure. Okay. When subjected to high horizontal forces, okay, the soil in the site may be expansive or collapsible. Okay, ito yung mga weak yung soil sa site. Okay. Foundation subjected to uplift forces. So yung uplift forces, magkakaroon ng uplift forces because of this horizontal forces. So for example, ito. Okay. So magkakaroon ng uplift yan kapag, 'di ba, if you recall yung formula for uplift is yung factor safety gains overturning is yung RM over OM, di ba? Yung RM over OM, righting moment divided by the overturning moment. So kapag hindi malakas yung righting moment mo, ay yung overturning moment mo, mag-overturn siya, di ba? So basically, kapag hindi ganun ka laki yung weight ng yung pressure dito sa soil and hindi niya kinaya yung tulak na yan, yung lateral loads na to, okay, yung lateral load na yan, magkakaroon ng uplift on this side. Okay. So as you all know, so di ba P over A plus minus MC over I, di ba? Okay. If your pressure, itong soil pressure mo, magkaroon ng tension side, okay? Magkaroon ng tension side, ibig sabihin ang soil pressure sa ilalim is naging ganito. Ito yung compression side, for example, and ito tension side. Tension. This one is compression. So hindi natin hinahayaan. Ito yung compression. So hindi natin hinahayaan na magkaroon ng tension side sa soil because your soil cannot handle tension. Okay? 'Di ba yung soil is only for compression. So we are assuming that yung soil is not capable to resist tension. So hindi mo naman wala namang tensile force capacity yung soil. So that is why hindi natin hinahayaan na magkaroon ng tension side dun sa pressure diagram. Kung mapapansin nyo, both itong mga negative P over A plus minus MC over I, puro compression yan dapat. Okay? So puro compression yan. Okay. So pag nagkaroon ng tension, meron yung uplift forces and hindi naman pwede na mag-overturn yung ating soil. Hindi naman yung soil natin na sasabihin natin is hindi niya naman hahatakin pabalik yung soil na to. So wala namang tension dito na tension rod dito na ibabalik niya pababa. Okay. So that is yung uplift forces. So kailangan mong kapag ganyan yung scenario mo, teka, mag-iisip ka, parang hindi yata pwede isolated footing dito or shallow foundations. Maybe kailangan kong gumawa ng micropiles, okay? Or maybe mat foundation. So let's see. So titingnan mo kung ano ba yung mas a designer, titingnan mo kung ano ba yung mas economical doon sa dalawa. Okay. And also yung mga bridge abutments and mga piers, okay? So this one yung mga abutments sa mga tulay. Okay, so weak din kasi yung mga soil dito eh. So basically kapag mga ganito lalo na sa may mga water bodies sa ilalim. So no choice ka kundi kailangan mo mag-provide ng foundations. Okay, yung mga deep foundations. Okay. Then also kasi ang mangyayari kapag shallow foundation lang yung mga ganito, kailangan mo kasi ng malalaking dito malalaking poste, malalaking piers. So kapag gumamit ka lang ng shallow foundations, so magiging sobrang slender naman yung columns mo. So basically hindi yan pasok sa capacity ng mag-equate dun sa demand ng loads. Okay. So what are the types of piles based on the materials? Okay. So number one, so pwede mong gawin is timber piles. Okay. So this one is hindi na to gaano ginagamit. Okay. Bakit? Bakit hindi ganun ginagamit yung timber piles ngayon? Kasi dati, mahal yung concrete. So, syempre, hindi pa ganun kadami yung production ng concrete and ng steel or reinforced concrete. So, the solution is to provide timber piles. So dati kasi medyo mas mura yung timber piles compared to the concrete. So wala naman silang choice kung hindi mag-timber piles because yun yung mas maraming resources and mas mura, di ba? Okay. So anong problem nitong timber piles? Okay. Kasi kung timber piles ang gagamitin mo at hindi mo siya na-treat, okay, kahit ma-treat mo yan, magkakaroon pa rin yan ng masisira pa rin siya dun sa yung timber piles mo because any timber kapag resting on the natural ground is masisira, 'di ba? Masisira 'yon. So hindi siya ganoon kataas yung expected lifespan of a timber piles. So that is the problem. So etong mga to ginagamit to dati sa yung mga lumang panahon, mga 19 something pa. Yung hindi pa ganoon kalaki yung hindi pa ganoon kamura yung concrete and steel. Okay. So, yan yung timber piles. Okay, number 2 is yung steel. Okay, yung steel piles. Okay, may problem din dito sa steel piles. Okay, the problem again for steel pile is the same dun sa timber piles. Okay, yung steel cannot be exposed to natural ground because magkakaroon ng corrosion, di ba? And pag nagkaroon ng corrosion, ang mangyayari, maka-compromise naman yung strength ng foundations mo. Okay, so just like yung timber piles, okay, ayan yung sa steel. Okay, then we have yung most common na ginagamit talaga ngayon is yung concrete piles. Okay, or the reinforced concrete piles. Okay, so concrete piles or the reinforced concrete. Okay. Basically, yung reinforced concrete is ito pala yung letter E. Okay. So yung concrete pile is may gumagawa nito pure concrete lahat. Okay, yun yung ginagawa nila dati. So pure concrete lahat, ito. Okay. So the problem with this one is masyado siyang brittle, di ba? Bakit brittle? Kasi walang tension capacity, walang tensile capacity yung piles. Dahil 'di ba ang concrete is high in compression but very weak in tension. So kapag hindi ka nag-provide ng reinforcement dun sa concrete piles mo, so the failure is more brittle, okay? Ibig sabihin para siyang sa Tagalog is malutong. Mas malutong siya pag nasira. Okay, pag nag-crack siya, para siyang chocolate bar kapag krenak mo, 'di ba? Napuputol agad. So parang ganito yung mangyayari kapag concrete piles yung gamit. Pure concrete. Okay. Then we also have yung composite piles. So this one, mas malakas na to. Okay, since pinagsama mo na yung steel section and yung concrete. Okay, so this one, ginagamit na rin to ngayon, yung composite pile. Okay. And ang downside naman nito, mas mahal siya when compared to the reinforced concrete. Okay. Using yung rebars sa mga rebars dito. Okay, so as a designer, you should check the cost-benefit analysis. Kung sino ba yung mas economical sa dalawa. Okay, and then lastly, we have the drilled shafts and the board piles. So hindi na, most common term kasi dito sa site is yung board piles. So hindi masyadong binabanggit yung drilled shafts. So board piles. Okay, board piles is basically itong reinforced concrete ng column na to. So para kang may reinforced concrete column dun sa ilalim. Okay, so paano to ginagawa? Ang ginagawa dito, magkakaroon ng casement dun sa soil. Okay, ilalagay yung casement. Okay, so then ilalagay nila yung reinforcement. Then after that, meron yung mga sensors para malaman if may honeycomb dun sa pag-pour ng concrete mo. Alam yung honeycomb, yung sa Tagalog is ampaw na buhos. Okay? Pag medyo may ampaw dun sa buhos ng concrete column nila. Yan. So kailangan na lang i-check. So kailangan may provide ng sensors dito. Yan. So kapag merong kakandak ng poured piles doon sa sa site nyo. Yan. Okay. So ito yung board piles. Yung drilled shafts naman is pwede siyang i-drilled. Okay. So what are the types naman based on the load assumption? So ito yung tinatawag nila na geotechnical pile types or yung type of piles based on the load assumptions. Okay, so as a designer, ito yung mas palagi mong maririnig sa office or sa design. Okay, Ang tatanong sa'yo, ano ba yung pile foundation nyo doon? End-bearing piles ba or friction piles? Okay. And this one, yung end-bearing piles and friction piles is the one that we are going to design in our module 19. Yan. So for the end-bearing piles, yung pile will transmit load into the firm soil layer on the ground such as rock, gravel, and very dense sand. So basically, yung end-bearing piles, okay, the load assumption is walang skin friction and tanging parang naabot niyo yung bedrock. Naabot niyo yung very strong soil sa ilalim. And kapag naabot niyo yung very strong soil sa ilalim, kaya siya tinawag na end-bearing. Okay, so parang ano lang to end-bearing. Q-tip. Okay, so parang ganito. Nag-load ka dito, let's say this is P, naabot mo yung assumption na very high, very strong soil or yung bedrock. Okay, so as summation forces vertical or equilibrium, kung ano yung total force P dito, yun din yung force dito sa ilalim. So kaya siya tinawag na end-bearing kasi yung capacity niya is nakadepende lang doon sa end bearing. So, depende doon sa contact area, di ba? Kung ano yung contact area, mas malaki yung contact area, mas malaki yung capacity. So, ibig sabihin, mas malaki yung section, mas malaki yung capacity. Okay? So, yan lang yung end bearing piles. So, dito lang siya nakadepende yung capacity niya doon sa contact area. For the friction piles naman, ito yung pile transmit the load from the structure to the penetrable soil by means of skin friction or cohesion between the soil and the embedded surface of the pile. So this load assumption, okay, tutulong yung soil. Tutulong yung soil yung cohesion ng soil dun sa capacity ng piles. So the assumption is walang end bearing, okay? Ang meron lang is yung skin. So di ba may cohesion value yung inyong soil? Then therefore, meron yan ditong mga ganito. Ayan, yung mga skin friction yan. So summation forces vertical, again, yung load P is equals to the summation of your skin friction. So, let's say, yeah, F na lang, summation of skin friction. So, yan. So, linear meter yung mga skin friction na yan. So, that is the assumption for the friction piles. So, again, the end bearing piles is kung ano yung contact area. And for the friction piles is yung based on the skin friction or the cohesion of your soil and the surface of the piles. Okay. Then we also have types of pile foundations based on construction. Okay. So, di ba yung una based on material, number 2 based on the load assumption, based on the construction. Okay. So, meron tayong dalawang ways how to construct your piles. Number 1 is yung displacement piles and number 2 is yung non-displacement piles. Okay. Bakit tinawag na displacement and non-displacement? Displacement piles, it cause the soil to be displaced radially as well as vertical as pile shaft is driven or jacked into the ground. Example na ito is yung driven piles. Okay, displacement piles, okay, by the word itself, displacement. Okay, so meron kang kung ano yung nakikita nyo dyan sa site, sa most common dyan sa mga area na yan, yung so, meron kang piles, ipa-pile driven mo siya. Okay? So, kakanta ka ng hammer testing, ng pagka-hammer dito, then magpe-penetrate siya dun sa soil hanggang mabaon yung total piles. Okay? And number 2 is yung non-displacement piles. It causes the soil to be removed and yung resulting hole, i-filled mo siya ng formworks, then yung casement mo, then a concrete or a precast concrete. Okay, pwedeng concrete doon ka magpupur or pwedeng precast concrete. So, ibig sabihin, nakas nila sa labas, then ibabaon na lang nila yung doon sa holes yung pile foundation. Okay, after dropping doon sa hole, kailangan nilang mag-grout. Okay, ilalagay nila ng grout or palalagyan nila ng mag-fill sila ng grout So yung grout mo is high compressive strength, non-shrink grout. Okay? So yan yung ilalagay nila doon. So para ma-compensate yung void spaces. Okay. So for example of this one is yung drilled shafts and yung board piles. Okay. Ito yung non-displacement piles. Okay. So what are the methods of installation? Okay. For the displacement piles, meron tayong tinatawag na mga drop hammers. Okay. Meron din tayong diesel hammers, okay, vibratory hammers, and jacking method. So the problem for the displacement piles is medyo makaka-istorbo ka doon sa nearby areas mo. Okay, because kapag nagkakanda ka ng pile foundation, okay, nagkakanda ka ng displacement piles. So, yung mga nearby area mo is masyadong maingay ito yung displacement piles na to kapag every drop ng hammer. So, naalala ko nung college ako doon sa ginagawa yung katabi nung ST building sa labas. I think yung bagong McDo doon sa San Marcelino, then di ba may isang building doon na nakatabi. So, I remember yung nung nagkakaroon ng pile driving doon. So, sobrang nakaka-istorbo talaga doon sa klase namin. Sobrang lakas, sobrang ingay. Okay, so, yun yung problema for the displacement piles. Okay, wait lang class. Okay. Naririnig niyo ba yung yung kandidato? Yung kanta ng kandidato?
Yes po, sir.
Lakas na. Okay. For the non-displacement piles naman, ito yung mga board piles, mga ganyan. Drill borehole, set rebar cage, then you can pour concrete. Then, pwede naman dito, isa pa, pwede kang cast, yung precast, okay? Yung precast, then grouting. Yan. So, yan yung for the displacement pile, non-displacement pile. So, magdi-drill ka ng borehole, then set rebar cage and pour concrete kapag doon mo siya ipo-pour yung concrete. Doon mo ipo-form yung rebar. Yung reinforced concrete mo. Then, meron pang isang case is kapag precast. So, drill borehole again, then precast, lalagay mo yung precast mo, then grouting. Okay. So, that is for non-displacement piles. Okay. So, what are the forces acting on the pile foundations? Okay. Katulad ng sinabi ko kanina, di ba? The load assumptions, meron tayong skin friction and the end-bearing piles. Di ba? Ito yung skin frictions. Sige, malapit na tayo. So, ito yung skin frictions. Okay. And this one is the end-bearing piles. So, we have your compression side and we have yung active. Okay, so kapag magde-design kayo, kapag you are now a structural engineer, magde-design kayo. So, gagamit kayo ng software, di ba? So, gagamit kayo ng software. Then, mapapansin kayo dito, pag nagde-design kayo, so meron yung pile cap. Okay, don't forget na kapag lahat ng pile foundations ay merong pile caps. Okay. Ito yung column. Okay, then ito yung piles. Yan yung piles. For example, tatlo lang. Yan. Hindi nabot. Ayan. This one, ang tawag dito is the pile cap. Okay. So, pile cap, parang basically ano lang din siya isolated footing na may pile sa ilalim. Then, you have your embedment. And yung reinforcement nitong embedment, yung embedment nito is should have a minimum of 150 millimeters. Okay, yan yung minimum embedment. Okay, the problem with this one, paano yung reinforcement yan, sir? Okay, meron kang pile cap. May piles ka, then lalagyan mo pa ng pile cap. Then after that pile cap, lalagyan mo pa ng, doon may lalagyan mo loop. Paano yung reinforcement nito? So, paano rin ito kinoconstruct? Ang unang gagawin dito is, construct mo muna yung piles. Maybe maybe displacement piles or non-displacement piles yung method for constructing your piles. Okay, so for example, driven piles na lang. Yan, driven piles. So na pile driven na nila. Okay. May reinforcement yan dito. So nakaganto yung reinforcement niyan. Yan. So nakaganyan yung reinforcement niya. So kapag nag-pile driven kayo, wala na sa akong picture eh. So sa dati ko sa. Okay, so kapag nag-pile driven kayo, yung mangyayari dun sa after mag-pile driven, okay, expose yung mga rebar niya, expose. So this is high tensile rebar. So most common dito is mga grade 70. Okay, 70 KSI yung rebar na ginagamit dito. Okay. Then, ayan. So, expose yung rebar na ganyan. May embedment siya. Then, after that, maglalagay ka ng pile cap. Okay. So, ang pile cap, reinforcement ng pile cap. So, para siyang, para din siyang isolated footing. So, ang gagawin mo, meron kang ganito. So, ito yung rebar mo. Okay. So, meron kang rebar sa taas. Okay. Sorry. So, may rebar ka sa taas. Then, may rebar ka sa ilalim. So, yan kasi yung actual. Yan. So, ang ano dito, pwede siyang ituloy yung rebar. So, continuous yan dito. Okay. Or pwede maglalap. Okay. So, mag-splice na lang sila. So, pwede mag-splice. Okay. Splice na lang natin. This one. Then, ito yung reinforcement mo. Yan. This one. Okay. Then, sa taas, meron ka rin. So, yung reinforcement sa top class is for the compression side. Okay. So, if you recall how to design yung beam, di ba? Meron tayong doubly reinforced and singly reinforced beam. So, parang ganito rin siya. So, kapag hindi na kaya ng single layer, so, ang solution is to provide compression steel. So, parang ganito rin yung case na to. Okay. Then, meron kang rebar no in yung piles. Yan. Okay, yan. So, imagine, napakarami yung reinforcement dito. Okay, so, the forces acting on the pile foundations, pwedeng mangyari, ito puro compression. Compression, yan dito sa isang side, tension. Okay. Dito sa kabila naman, compression. Ayan, so pwede magkaroon ng compression and tension. So for example, ito yung forces sa top. Yan. So pag nagde-design ka using computer software, makikita mo na may compression side, may tension side. Ayan. So yan yung makikita nyo sa pile foundations pag magde-design. Okay? And what is the determination of the pile capacity? We have two verification of the capacity of the piles. Number one is based on prediction or yung theoretical. And number two is yung verification. Yung prediction is based on the site investigation and laboratory tests or yung formulas na pwede natin gamitin for predicting the theoretical capacity. So, ang mangyayari kasi dito, class, so bibigay ni geotechnical engineer yung foundation solution. So, let's say deep foundations, pile foundations. Then, bibigay niya yung total length. Okay. Then, assume yung capacity. Sasabihin niya muna, ito yung theoretical value natin for the capacity of the piles. Yan, yun yung gagawin. So, kasi yan, simultaneous yan nangyayari. So, kailangan, ang dapat maging open na kayo kapag dating ng structural engineering, ang ang kalaban natin dito is time. Okay, yung schedule, yung tight, sobrang tight ng schedule pagdating sa structural engineering. Okay. So, ang mangyayari kasi dito, may bibigay ni geotechnical engineer, ito yung assume theoretical value natin. So, yung binigay niya sa'yo, mag-start ka na mag-conduct ng design. Yan. Then, after that, yan, bibigyan mo na yung plans. And then, kapag dating sa construction, nag-verify na sila. Siyempre, unahin yun, foundation. So, magkakaroon sila ng verification. So, dito nagkakaroon ng problem. So, ang verification is pwedeng static pile load test or dynamic pile load test. So, you can check na itong static pile and dynamic pile loading. So, yan yung pag-check ng actual capacity. So, minsan, nagkakaroon ng problem. Okay, let's say, ang binigay ni geotechnical engineer, the capacity is 30,000 kilonewton. Yan yung capacity ng piles. But, pagdating doon sa verification, so dito ka dito ka nag-design. Ito yung preliminary design mo. Ito na yung parang pinaka-design mo. Pagdating sa verification, nag-using static pile loading or the dynamic pile loading, na-determine na capacity pala is 8,000 lang. Pwede yan, nangyayari yan. Or also, pwedeng 10,000. Ang pinaka-grabe nung na-experience ko is nasa 60% yung below. So, pwedeng let's say ano na lang, 10,000. Yan, 10,000. 10,000 kilonewton yung nangyari. So, ano yung conclusion? Bagsak yung design mo. Tama ba? Siyempre, dinesign mo siya ng 13,000, pero yung actual pala is 10,000 na yung capacity. So, in conclusion, bagsak yung design mo. So, anong gagawin mo ngayon? Gagawin mo ngayon, popropose ka ng panibagong files. So, bago ka mag-propose, you need to verify muna yung loadings mo. Tama ba yung loadings mo? Pwede mo pa bang ma-optimize yung design? Okay. Yan yung mga cases. So, gumamit ka ba ng finite element analysis or just linear static lang? Okay? So, yan mga cases, or pwede mo i-consider nonlinear capacity. 'Di ba yung nonlinear capacity, if you recall, mas mataas yung nonlinear based on dun sa linear capacity. However, medyo mahirap, mas complex yung pagde-design kapag nagamit ka ng non-linearity nung gagamitin mo yung non-linearity nung material. So yun yung problem. Okay, so ayan yung mga typical problems na ma-encounter nyo when you are working as a structural engineer. Okay, so ang experience ko dito is medyo madugo talaga yung pile foundations kasi medyo madami. Okay, madami. Then ano pa? Meron din tayong mga you can check yung different piling layout. So meron tayong different piling layout. So pag mga tatlong piles, ang piling layout niyan is this one. Yung mga piling layout niya. So you can check yung mga typical piling layouts. So pag apat, pwedeng ganito. Okay. Yan. So, any questions before we end this meeting? Okay. Sige. So that's it for today. So thank you and see you on Wednesday.